Okay guys, so today we are going to talk about combustion analysis in CH110 when you have been asked to find the empirical formula or molecular formula using combustion analysis. So to combust means to burn. So what we are going to do is we are going to go straight to the question. We have been given a question, so we'll go straight to solving this question. So we can collect the data. So let's say data. So in this question, first of all, you have to see how the value that you have been given and the samples. So we have carbon, hydrogen and oxygen. Then you also have carbon dioxide and water. So let's collect the data. The data for the mass number for CH&O it is 0.289, or I mean 0.1005 grams. So let's collect. So CH&O, the mass is 0.1005 grams. Okay, so for carbon dioxide it is 0.282 grams. For water it is 0.1159 grams. Now we know that for us to find the mass in carbon dioxide we only have one carbon. So let's find the mass of carbon in carbon dioxide. So I can say mass of carbon. So first thing first, we are going to get the mass that you have been given in carbon dioxide, which is 0.282 grams multiplied by the mass number for carbon, which is 12.01. Some on your periodic table you will see that it is 12 grams per mole, but I'll use 12.01. That's what it shows on other periodic tables. So then you divide now by the molar mass or molecular formula for the entire carbon dioxide. You know that this is carbon, so oxygen is 16 multiplied by 2. Carbon, it is when you have one carbon, it is 12.01 times 1. When you have 1, for oxygen you have 2. So the answer is, so you have to add the two answers. Yes. So it will give, this is H2 plus 12.01 to give you 44.01 gram per mole. So that's what, this is the value I'm going to give to put it here. So it will be 9 by 44.01. Yeah. From here, now we punch. So I have a calculator here. So say 0.282 times 12.01 divided by 44.01. Okay, so when you punch this, it will give you 0.076955. We can end here. So this is the grams. This is the mass for carbon. Let me even indicate carbon. Now let's look for mass for hydrogen. We are dealing with carbon, hydrogen and oxygen. Let's go now to find the mass for hydrogen. We're going to find the mass for hydrogen in water. So we have the sample for water, the grams for sample for water is, so I'll say mass of hydrogen. So we have been given it is we have 2 hydrogens. So we are going to carry even the 2. So on finding the mass number for hydrogen, you will say the mass number for hydrogen is Z. So I'm going to put times. It is 1.008. Now I'll multiply with these 2. Okay, we have 2 hydrogens. So I'll put 2. So when you find, let me see how it will. So on finding, like I said, you have to divide by the molecular mass for the entire compound, which is water. We're dealing with water. So for water, H2O, oxygen, it is 16. Hydrogen, 1.08 times 2. So when I'll say 1 times 2, so this will give us 18.01. That's the answer. So I have gotten this number and I put it here. So when you punch, it will give you something like 0.01297. Yeah, we are able to give us 2 numbers, but I went there. So this is the mass for hydrogen. Now, for us to find the mass for oxygen now, we are going to say the mass of the entire sample, which we have been given, this is the mass for the entire sample. So let me say, I'm sure it's visible here. So it is, to find for oxygen, I'll say mass of the sample minus mass for carbon plus mass for hydrogen. This will be the mass for oxygen. So mass for the entire sample, it will be 0.1005 gram minus, what's the mass for carbon? This is the mass for carbon, 0.069555 minus, plus mass for hydrogen, this is the one, 0.01297. You can put. I start? So when you punch like this, when you put this on your calculator, it will give you something like 0.010575 grams. This is your mass for oxygen. So we have done finding the mass for carbon, mass for hydrogen, mass for oxygen. Now we can proceed to finding the empirical formula. I'm going to have this. So this we are the masses we collected. This we are mass for carbon, mass for hydrogen, and mass for oxygen. Now when you reach this state, that's where we divide now by their mass numbers. So for carbon, we know we're going to divide by 12.01. For some we use 12, but for me I'll be using this one. Periodic tables differ. Divide by here, it is 1 point. You can put the video. So even here, I'm going to use 1.008. Here it is 16. So you should use the numbers that we are going to be given a periodic table. So you should use the same periodic table that will be there. The number that will be there. That's what you should say. So now I'll proceed. So when we divide this, I'm going to have, you can pause. So it will give you something like 0. But you should always confirm with your calculator. So it is 0.006407.5. This I load. So in there. Here to give you something like 0.01 0.0128 7. I go even here. 6, 0, 9, 8, 7, 5. We can start. So when you do this, it will give you something like that. From here now, we are going to divide everything by the lowest number. So let's start thinking. This is 0 0.00, 0 0.01. So this one is less than this one. So 0 0.00, automatically this is the less number. So we are going to use this one. Divide by 0 0.0006609. Even here 0 0.0006609 375. 0.0006609 Let's see the answer we are going to get. So when you punch to give you 9.69, okay, we end here. Here when you punch, start. So here to give you something like 19.6. The values are not that important. So move to, for this one to give us 1. So when you reach this stage now, this is 9.6, 19.6, this is 1. When you have a number here greater than 5, you can round it off. Even here greater than 5, you can round it off. But if it was, let's say for example 4 or 4, you are going to look for a number that you multiply everything so that it gives you a whole number. Yeah. So when you round it off, this one will give us 10, this one 20, this one will remain 1. From here now we can bring the numbers. So we have C it is 10, 8, 20, and oxygen 1. You can just ignore it without even writing it. Yeah. So this is your empirical formula. Yeah. So this is the answer. Thank you for watching, and I'm sure you're going to say